Hi. Thank you for the nice view of what's ahead of us for Checkmk SaaS. Now, let's take a different view. So how do we get here in the first place? Now, when we started all of this, we had essentially two problems. The first was preparing Checkmk to run as a SaaS product. And then we also need to actually build a platform to run it on. So let's start with Checkmk. What did we actually do here? So one of our goals was to make it easy for you to use and easy for us to run securely. So what does it mean? Let's start with you. We want Checkmk to be easy to use by design, so the default option is secure. It's easy there. Okay, what do we have on-premise? Checkmk instance and your hosts, they're on the same network. You install the agent, you configure the host on Checkmk, and then Checkmk pulls the data. That's great. Works good. But now we're in a SaaS world. We run Checkmk for you. We don't have access to your host anymore. Okay, what can we do? We push the data from the host to Checkmk. That's great. And since version 2.2, we also have the push agent mode. It's good. Pushes data securely to us. But it's not the default agent. You have to install it and have some extra commands, or you configure it extra so it's baked with it. Not really great in usability. So we decided to make it easy to use and the default option. So with the onboarding we have now, we also pre-configure an agent. Once you install the agent, it will automatically register itself with the site. It creates a host for you, and it will start to push data. And another thing for the easy part is, in our configuration, you have an easy two-step install process. And after that, we went one step further, and we actually completely disabled the pull mode. So Checkmk and a SaaS product is not able to pull data from your host anymore, as we don't think this is secure anymore. Good. Now, it's a lot easier for you to have secure monitoring. What about us? We also want to run this securely. Okay, so we have our infrastructure, you and your Checkmk site, and we also have a lot of other customers. But is anybody up to good things? Maybe not. So we actually have to assume some people will abuse what we have and provide here. Now, one thing that I also learned that was new for me, if you're an administrator and you run Checkmk on-premise, we actually provide remote code execution for you as a feature. Like, the most probable examples there are extension packages to run arbitrary Python code, or some rules like individual program call instead of agent access. If you configure this, Checkmk will run any command line program you configure now when it checks for a host. This makes it easy to have a reverse shell on your Checkmk server. It's great for administrators, and it's great on-premise, where you have everything you want to do, and we want to give you all the flexibility. Now, in SaaS, we still want that you're administrators. You have to configure Checkmk, right? But at the same time, I don't want that you reverse shell onto our containers. So we actually have to prevent this. So we have two steps. The first is some features, like the MKPs, we actually disable in SaaS. And rules, we have a little bit more dynamic approach. So when Checkmk starts, it will actually ask one of our backend services, hey, which rules am I allowed to show the users that they can use? And then only show you those. So the rule individual program call instead of agent access, you will not be able to use in SaaS. And this rules list is also regularly updated. So Checkmk every 10, 30 minutes checks, hey, which rules are still allowed to use, and then disables the ones we say no anymore. This is there in case we notice somebody's abusing a rule that we did not anticipate before. And it's also updated regularly by us, because Checkmk is always evolving. We add new Checkmk agents, new plugins, so that you always can use everything that we deem as secure. And these changes make it a lot easier for us to run Checkmk securely for you. Good. Now, we're done with Checkmk. It's better with the security here. Next step is we have to build a platform to run Checkmk on, actually. And here, the two problems for me I want to highlight are authentication that we have to solve and how do we actually update Checkmk. So Checkmk Cloud, what is it for you? What you see when you interact with Checkmk is Checkmk. You use this to monitor your infrastructure. And the other piece is our administration panel. This is there for you to have your sites, manage them, see if they're up or not, manage your users, your license. And this is a completely separate application from Checkmk. Now, to access this, access your information, we also need to authenticate you. And we need to do this also for Checkmk. Now, when we had this, we had some goals. We want this to be seamless for you, right? It's one cloud product, so if you change between the admin panel or if you change between Checkmk, shouldn't matter. You logged in once, and then you can change back and forth. It should be self-service. You don't have to ask us if you want to create an account or if you want to reset your password. And of course, it has to be secure. So we built a centralized authentication service. So now every time you go either to the admin panel or to Checkmk, you're forwarded to our login authentication service. You type in your credentials and then route it back. This is based on the OAuth2 protocol for communication between our service and the applications, and AWS Cognito, which securely stores your credentials. Now, when we did this, we also learned the hard way, good user experience in authentication is hard. So I want to give you one example. Say you heard from a colleague, we're now offering our SaaS product. You think, this is a great idea, I want to try it. So you go to the free trial page, you start entering your email, your password, and then you come to our verification screen. But now something happens. A friend comes in or colleagues, they have an urgent problem and ask you to help them, and you say, you're a good person. So it's, yeah, of course. So you leave your desktop, go and help your friend. It takes a long while. You forget about this for the day, and the next day you remember, oh, right, I wanted to try this out. OK, you go again to the trial page. You enter your email, your password, and you want to continue. At this stage, it's actually not clear what we should do. What is a good experience for you? First thing we thought of, and most people know, is we just tell you, hey, we already have an account with this email. Please go there, log in, and then we show you any further steps you need to do. But this has two problems for me. I think it's not good user experience for you because you have extra steps involved. Plus, potentially anybody can do this and figure out if you have an account with us. I don't think it's anybody's business if you have an account with us besides you and us as a company. So what we do instead now, we just show you the verification page. In the background, we send you a new verification code, and you can log in. It's fewer steps for you, and nobody else knows what's going on. With this, we found also some other places where we can do the same thing. Now, that was the authentication. Last part, how do we update Checkmk? What do we want to do when we update it? So updating should be minimal impact for you. Right now, when we update Checkmk, we still have to stop the Checkmk site for a few minutes, and then it comes back up. So maybe we don't want to do this at 8 a.m. in the morning when you start your day. Instead, we're doing it in the night. Important for us now for this process also, potentially has to work on thousands of sites. We want the product to be successful. So then we went and we automated everything. Now, the last step, we want this to be reliable, and that was the hard part. But what does reliable mean for us here? So for you, it means every morning when you start your work, your Checkmk site is working and running. It doesn't matter what happened with the update during the night. Now, the other part is, me and my SRE colleagues, we like our sleep. So if there's a problem with the update, we would like to continue sleeping, get notified about it, and solve it in the morning when we're fresh and rested. Now, how did we achieve all of these things combined? That's a tough question. We start actually before we do your update. First bit is that we heavily test and invest in QA. So the update part is tested on all the additions daily. And here, thank you to our QA colleagues, which did a great job in improving this testing in the last cycle for 2.4. Then We also go and take the development version, so the next major release, the next patch release, and check it in SaaS, make sure it works OK in our environment and our platform. And the last bit, we have a backup and restore functionality, and we are also testing this. So in case something happens, we can restore your site. OK, great. We are sure update works, the version works there. We have backup and restore. Now we can go and update your site. Now, next thing, I'm very paranoid, and I really like my sleep. So maybe we didn't cover something in the update tests. So the process we now have is that before we update your site, we take a backup. Then we run the update. After the update, we make sure your site comes back up. So we wait until Kubernetes reports us this site is running and reachable. If it does, yeah, cool, we're done. If it doesn't come back up within 10 minutes, we're going to say, OK, something happened here. Let's better restore the backup. I have an alert notification. I see the logs from the update. And we try again the next day after we figured out what went wrong. Cool. Now, you might think we're done. Everybody can sleep all the time. Not quite. There's still a chance this takes some time. And during the update, this process might crash for some reason. AWS takes a node away. Something else happens. Cosmic rays. Who knows? I still don't want to be woken up by this. So the last bit we have to do, this update job also has to handle any errors. The first bit here is that we run it as a Kubernetes job. Now, Kubernetes takes care that if this job crashes, it will restart it again. If the node dies, it will restart it again. And the last bit is we have to handle these restarts a bit gracefully. So let's say we're in the update, the job dies, it restarts. We don't want to take a backup again. So what we do instead, every time we do an update, backup, we go there, the job stores in the database, hey, I just did that. And when it starts again, it says, oh, OK, I already started the update, so I'll just wait and see if I maybe have to restore you. In most cases, it's very, very successful. After we now have done all of these steps, you have a working Checkmk in the morning, and we all can sleep. Now, this concludes my part of this talk. And there's a lot more, though, that it takes to make a great platform for a SaaS product. And now Cristian will tell you the rest.
Thank you very much, Max, for all the insights on the container authentication updates. I'm part of a team of great engineers, and I'm sure there are some more great engineers in this room. So what we will try to do is build a SaaS platform together in, 10 minutes. First of all, what are the most important pillars for us? Scalability, security, reliability. Really, you have to start here. And we start with scalability. It seems easy, right, to build something scalable. But this is Checkmk. Not everything is that easy. And in order to build something scalable, you need to consider the number of sites you're going to have. It can be 0, it can be 100, 1,000, who knows. Then you have the number of services per site. Some customers have few services, some have hundreds of thousands. And lastly, where we will do all our monitoring. Location, location, location. So let's start with the number of sites. When we started this journey, of course, we had to bring a lot of sites. A lot of them are mostly trials, so they have certain characteristics, right? They are on-demand, short-lived, and ideally, we have to make them cheap. And that last part, if you've been paying attention today, is a little bit tricky to achieve. And I'll tell you why. Let's look at the services per site. The more services that we have on a site, the more compute we need. But Martin said today that's going to drop. And then we need more and more and more memory. So this becomes a tricky balancing act. And for trials, it's even more tricky. Because the minimum requirements, Moritz said 150 megs. Luckily, it's turned off by default. So the minimum requirements are already high. So we have this to keep in mind. Now, the last challenge, I want my monitoring to happen, to be regionally hosted. in America is the same. Anywhere else in the world is the same. Location, location, location. We need to support some locations right now, and we have to grow the number of locations in time. How do we tackle the scalability problem together? First of all, no brainer, no touch ops, click ops, nothing like that. Infrastructure as code from the beginning. And also, it seems simple, and you think, oh, you're doing infrastructure as code. As the infrastructure expands, you'll have some new, very exciting challenges. But I'm part of a team of great engineers, so that part is sorted for us. On-demand resources. 1 trial, 100 trials, 1 real customer, 100 real customers. We need to scale this infrastructure somehow, and it needs to scale fast. We don't know how many trials we're going to have. We don't know how many campaigns we will have. We don't know when they are, so it needs to scale. This one, between us engineers, is tricky. We need to do resource pooling somehow, optimizing cost performance. And there are 2 camps here. Some of you will go with just put instances there, EC2 instances for the win. It makes sense. And there are some other people that say, no, 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 containers. They're the better solution here. We decided that actually containers do make a lot of sense. It's wild what we will have to support. It's incredible what will happen in our clusters. And we cannot wait forever for an instance to go down, come up. It takes too long. Containers are the better way to achieve this. We have containers. We need some sort of orchestration. Kubernetes is the easy way to do it. There are other ways, but we're going to stick with this one. And the last part, we want to scale across the world, across the globe. We need some hyperscaler, some cloud to do this. So this lays our foundation here. This is what we're going to build the SaaS platform on. And what does it look like at a very, very high level, super high level? So there's the control plane, and that's the part Max talked about, where the authentication happens, where we have the user management, etc. And this is where we're going to put the sites, in the application plane. These are individual accounts, and those are your sites. Containers of different shapes and sizes on different types of nodes. I should have made the nodes bigger and larger. It really doesn't matter. Right? We can accommodate anything. All this, of course, orchestrated by Kubernetes. We mentioned it. But herein comes some quick insights from the industry, if you haven't heard about them already. Scaling nodes. You have the cluster autoscaler, or if you're in AWS, the better tool, Carpenter. It's incredible, it's amazing, and it does some things really, really well. It can even figure out how to consolidate all the various shapes and sizes into bigger nodes, smaller nodes. It has some very clever algorithms, and it saves you money. Of course, we have all your sites. It was already mentioned, we have a backup process. It's handled with Blanaru. It's another great thing about being in the Kubernetes ecosystems. There are some amazing tools there you can leverage in order to perform certain operations. We'll come back to this in a while. And everything we're going to build on, we're going to use some infrastructure as code, Terraform. We're in Kubernetes, of course, Helm, and some version control system. And with this, we've kind of solved the first problem. We've laid the infrastructure. We kind of know the direction which we're going to go. So let's look at the security, because it's super simple. Security is easy now. It's amazing, simple, awesome. And we're going to start with the first challenge of the day. Any of you with EKS clusters in AWS? No, 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 no. We're the only ones, and we are the first in many ways. So we have this EKS cluster, and we have to spin it up, and you have to make already one choice. Do you go with IPv4, or do you go with IPv6? Now, the challenge is dual stack, and there is an or there, which doesn't make sense. You cannot choose both, so it's not proper dual stack. So that's interesting. Why is it interesting? Well, AWS says it works. We don't need to have the full stack. If you roll with IPv6, we're going to support all the legacy IPv4 endpoints, a legacy that's sure to continue for the years to come. So this is the idea. This is what you can do. And we're setting this one up. This was before we had a production to talk about, right? And as engineers, we know IPv6. Everyone's going to ask, do you support IPv6? And there were non-believers. So I waited, and I waited, and I waited until someone asked the question. And Martin has Lars, which creates one work. I have Martin, who asks the right questions at the right times. And basically, he asked, hey, are we going to support IPv6? And I was like, that's it, let's go. IPv6 cluster, full in. And all of a sudden, it started to crash down because a lot of the things were not ready for IPv6. Even our own Kubernetes monitoring wasn't there yet. We jumped on it, and we started to fix, and make things better and ready for IPv6 as well. Now, we thought this was going to be the end of it, but then it gets even more interesting. So we are in Kubernetes. In Kubernetes, there are namespaces, Checkmk site A, backups, ingress. These are namespaces, logical isolation. And you want to do some network policies. You don't want traffic to be flowing around. You want to put some restrictions. And the thing is, you want to block things, right? For example, the Checkmk site A wants to talk to the backups namespace. I don't want to allow that. I'll create a network policy. Is that blockable? Blockable. Checkmk site A wants to talk to the ingress namespace. Is that blockable? Blockable. But why would you do that? You need to somehow let the traffic flow back. You need to reach it. We're going to get to that in a second. So you wouldn't do that. You want to allow that. I want to create a network policy. Checkmk site A should not talk to Checkmk site B, i.e., two of you should not talk in my cluster to each other in any way, shape, or form. Blockable? Blockable. Thank you. And then we go towards more exotic use cases, right? So, OK, we have this, the Checkmk site A. Can it talk to an IPv4 host outside? Blockable? Whoopsie. And then you go Checkmk site A. Can you talk to a random IPv6 host? Can we block it? Blockable. But then, hold on a second. My Checkmk site, I cannot block it from talking to an IPv4 host? And we have IPv4 subnets? And there might be very good reasons why in the future someone will say, no, please, you're not allowed to reach my subnet, so please block all traffic to this IPv4 host. Big whoopsie. We relied on this. We thought this was going to work. It seemed like it should work, but it didn't. Now, if there was ever a moment when I doubted whether we made the right choice, that was it. That was the moment where, how can you build something where all your clients can scan entire IPv4 ranges without no restrictions? That could have changed everything. But we are great engineers. So we really try to look at the problem. What's happening there? We are in an IPv6 only cluster in AWS. IPv4 support, we read the docs, we go full in. It is supported via a virtual interface. Kubernetes network policies apply to primary interfaces. And of course, the virtual interface is not a primary interface. Therefore, you cannot block IPv4 targets. So once you understand what's happening at that level, you can come up with solutions. Now, brainstorming, you can replace the whole container network interface. Out with AWS, put your own, roll out your own, but then you lose AWS support. You can start doing some interesting hacks with DNS64, etc., but they're hacks. We are great engineers, so we really try to understand how are they normally implemented at the network, at the node level. How do all the other providers do it? And then you realize it's simple IP tables. Therefore, we implement our own custom solution. We block what we want. We can block ranges, individual things. And I can sleep well at night knowing that no one will try to scan my own range or the range you will be in. And of course, we're playing the waiting game here. A lot of people are crying out to AWS, please, it makes no sense. Please, we need proper dual stack support. So they will eventually do it, I'm sure. Now, do you remember the ingress? I mentioned it. I want to touch on it very quickly because it was interesting when we brought this whole thing up. This pattern should be familiar, right? You have the agent and users, and they are trying to communicate with their site. There's usually some load balancer that does some TLS offloading. Maybe something new is the ingress component there. Don't worry about it too much. It's there to guide traffic through Kubernetes. And basically, you reach your site. We basically create this pattern. We create the infrastructure. We put everything in place. And of course, there's no agent data. And we don't know why. Everything works. The interface works. We can do all these things. Just the agent data. And then we realize, hold on, there is MTLS there. What that means, the server tries to authenticate the client. And we're trying to mess with that whole interaction because we have TLS offloading on the load balancer. We can't touch that. Somehow, we must do something that fixes that problem. And the first solution is pass through all the traffic. Just let everything all the way to the container. It will work if you ever try this in some contexts. But marketing campaigns can be one site or 500 sites. And what you find, and what we found, is that, well, no. You will have some rate limiting. You're relying on a third party. If that goes down at any point, all of a sudden, a lot of your sites are not coming up. It's simple. It would work in many other scenarios, but not for us. Oh, and the second one, wildcard certificates, I can't even mention it. The security team will ask me if they even hear something like that. But you could. But we're never going to do that. Approach number 2, let's separate. Have another load balancer for the agent. It's simple enough. We're still good. No. That one was Cristian, actually. He said, no. The users will get confused. You will have 2 DNS names. They'll have to bake agents. It's a lot to remember, bad experience, no, no, no. OK, let's try to keep the same idea and add one more load balancer. And when I start to see something like this, my brain goes something like this. I cannot possibly accept this as a good architectural choice. It would make no sense. And if I have to do any troubleshooting, I'll never reach to any conclusion. So then we arrived to the solution we implemented. Basically, it's still simple, it's still elegant. And what happens here is that we discriminate the traffic at the ingress level. Again, if you have a great platform, if you're building on top of a great platform, you can do amazing things because you're not going to be the first one that has this specific problem. So this solves the problem, right? It's super simple. The agent, I can let it pass through. It goes straight. Nothing touches it. But web traffic still goes through the TLS offloading, and we can do our magic there if we need to. And very important, certificates are not in your container. This just scratches a little bit, right? We're building this quickly. We don't have time to go into all the other things. IAM, container security, Max touched on it, but there's more to it. And then you also have CM that you really have to think about. So we don't have time to go into great details, but globally or generally, these were the 2 of the most interesting, let's say, security challenges that we found. Now let's talk about the last part, reliability, right? And if you have the right level of abstractions, this is what we've built. And the level of abstractions, you have containers, you have Kubernetes, you have a hyperscaler. It shouldn't be that difficult. There will be challenges. There are challenges, but you can do things. So we're on call 24/7, and all of a sudden, a control plane service fails, authentication, licensing, whatever. We have the right platform in place. If this fails and a user gets negatively impacted, we've done something silly. Because you can just add redundancy. I can have multiple copies of any service. Better yet, I can put these copies on different nodes. Better yet, I can make sure that these nodes are distributed in different availability zones. So even if a whole pillar fails, a whole data center fails, the users will not notice anything. Let's say an individual node fails. We are on Kubernetes. There's auto recovery. And I touched on it. We have Carpenter, which takes care of the auto scaling. It's smart. Kubernetes detects a node went down. Carpenter takes over. And on average, in 5 minutes, a client site, our other services are way faster. A client site will be back up. We didn't have to touch anything. We didn't have to do anything. Auto recovery. Now, this one is tricky. It might be a phone call to us. We need to think about this one. A whole data center fails. For the control plane, it's all good. But for the clients, it's trickier. Those who work with AWS might know this one. Volumes are actually bound to an availability zone. But we have great backups. That's what we designed from the beginning. So what we can do is build automations to make sure that we can restore a backup into an availability zone that works OK. And within 20 minutes, everyone is back online. Now, I would still, personal choice, have an engineer that really looks at this. Because if you fully automate it and just starts kicking in, and in 2 minutes, everything solves itself, you're going to be in a very bad spot. Because then you need to wait for that. And then you also have to rebalance everything. It's going to be a mess. All this is really exciting stuff for us as engineers, for us, the SaaS team, who are building it from scratch, for those who are supporting us, for the beta testers. It takes a great team to build something worthwhile. There are a lot of pieces that need to work together, and they need to work really well in order to deliver a great user experience. I started with Checkmk. I was super confused. What we have now, when I spin up a new site, it's so much easier, a lot easier. And all those simple commands, copy, paste, amazing. So all these need to work together well in order to bring a platform. We have to have exceptional developers in order to figure out all this nitty-gritty that just irritates everyone. And when it all comes together, you have a great SaaS platform. Thank you very much for listening, and I hope you enjoyed our presentation.